OK， 目前看来质押应该是释放比特币上面资产流动性的非常重要的一个方式。那刚刚我们大家其实都抱怨说比特币没有什么可变动性，那我们的下一位演讲嘉宾会给大家带来的一个好消息。QED 来自于 QED 的策划人。哦，是这个。
Can we see? Can we turn on the projector? Okay. Where's the? Am I doing it wrong? Yeah, I'll just use my computer. Okay. How is this going to work? Well, so the clicker didn't work before. Wonderful. So, hi everyone. 就是今天我不会用中文，因为我中文不是特别的好，所以就是希望我用英文，大家都能接受吧。对。But yeah, so today we're going to be talking about the future of Bitcoin and specifically the future of Bitcoin development, since today is all about tech talks. Just a really quick intro on myself. So I'm Carter. I'm the founder and CEO of QED. And yeah, working? Ass. It's okay, no problem. So yeah, so I'm the founder and CEO of QED. I originally came from the more traditional security community. So as a teenager, I was a well-known black hat hacker. I developed the first console worm, so the first virus for game consoles that could spread from one game console to another. So if I infect you, when you go into other games, I could infect all the other consoles and get remote code execution. I was the head of Call of Duty exploit research at Xbox Underground. We were a rather notable hacking game at the time. We had a cover of, well, anyways, I won't go too deep into it, but we had a lot of media coverage while I was in high school. I also built ModPE, which is the only Minecraft Pocket Edition or mobile version of Minecraft, kind of a modding engine, because, you know, regular Minecraft written in Java, most modded game of all time. Mobile Minecraft written in C++, the only way to mod it before ModPE was to, like, you know, modify the ARM assembly of the game, which was rather tedious. So we wrote a script environment. Yeah, it was great. We had over 20 million downloads across both Android and iOS, and we built a developer community with like over 150,000 people. But yeah, I guess as far as blockchain goes, I'm also the founder of Rapid. So we were a proof-of-stake block producer operator, notably on EOS. We had like over 2 bills staked to us during the EOS peak. And process over 150 million unique transactions in production. And yeah, let's move on down. So just before we get into the tech talk, I do have to briefly plug QED. So QED, we want to position as the Bitcoin execution layer. We're fully trustless, as we'll see in a little bit. Yeah, it's decentralized. There's no multi-sigs, no Bithium, none of that. Yeah, don't send your Bitcoins to wallets that you don't control. We also built the L2O consortium, which is, we would like to say, the best consortium of top ZK L2s. And you know, we've got the likes of course, our friends here, but also Starkware, Polygon, and those guys coming over to Bitcoin through L2O. And we support the world's most popular programming languages. And on the developer side, I guess, it's also worth note that we're building a Bitcoin developer Reddit with, it's a JV between us and Bitcoin Magazine. So if you want to build on Bitcoin, you should definitely head over to r/Bitcoin Dev when it launches next week. We'll be having, like, I guess, lots of fanfare around it and lots of cool stuff. But yeah, QED is a really awesome protocol. It's way cheaper than transacting on Bitcoin with full Bitcoin security. So you get unlimited transactions for a fixed fee, and again, trustless peg in and peg out. everyone wants to develop on Bitcoin nowadays, right? And it's awful. It's really genuinely terrible. It's a horrible UX. Despite Bitcoin being one of the oldest and I guess best capitalized cryptocurrencies, it has by far the very worst tooling. We don't have a good scripting IDE, right? Like, when you wanna, if you go on, let's say, the Bitcoin talk or something, and you ask someone, how do I compile a Bitcoin script? They'll refer you to a command line tool where one of the inputs to the command line is your actual script. That's about as good as we have. In addition, like setting up a Bitcoin node is quite cumbersome. Like, you know, obviously you can install Bitcoin D, but usually if you're building on Bitcoin, you want to be able to start with a clean environment and do something like a CI/CD so that you can, you know, rapidly do things like unit tests and so on and so forth. And there just isn't anything there for us. So as a Bitcoin developer, it's really hard to get started, which is why we've seen such little innovation other than ordinals. Like ordinals was the first really big moment, but for a decade, we saw no one building on Bitcoin. Until now, right? So we built BitIDE. It's a full Bitcoin TypeScript IDE. You can implement custom opcodes. So I can make a polyfill for, let's say, opmul using existing opcodes that are enabled, and we'll actually go into that in a second. In addition, it has a built-in local testnet. So you run one Docker command, it starts up BitIDE. Well, it installs and starts up BitIDE, a full local testnet, and a block explorer, as well as an ordinals explorer. So you get all of that with one command. If you click Control-C on your keyboard, kill it, the environment's gone, it's deleted. You want to start up a new environment, hit it again, right? So we really built this with developers in mind, and yeah, I would love. I thought, because it was supposed to be like Tech Day, that people would have laptops and stuff, but I guess not that tech, right? But yeah, we can just do this real quick. So like, if you want to build an application on Bitcoin, just run like this Docker command. It will download and install BitIDE for you. And then it's as easy as, to get started. There we go. We now have a brand new testnet. And if I go to here, we have our wonderful IDE. So with BitIDE, something that would take you probably like a half an hour to set up with like command line tools, which was the previous preferred method, for like, let's say, I don't know, doing something like a pre-image puzzle lock, right? First of all, over here, I can kind of debug, whoops, that's for Dogecoin. We can see like a full stack trace of all the operations that we've done. And over here, you can actually see an example of the stack management that BitIDE gives you. So normally with Bitcoin script, if I have, let's say, like, I don't know, some variable I want to reference, I have to reference it by its position in the stack, which when you're making like simple Bitcoin scripts, like let's say something like you would do in the P2SH or page of script hash days before Taproot, it would make sense, right? Because your script length can't be that long. But if you have a tab script that's like 100 kilobytes, well then it starts to become a problem, right? So we have full tag-based stack management. So like over here you can see that with like square brackets. By the way, we call this like BASM. So it's like, I guess, a superset of the Bitcoin assembly language that compiles to Bitcoin assembly, as we can see. But yeah, so over here we have a polyfill for multiplication on Bitcoin. So I'm not sure if everyone is aware, but on Bitcoin, we actually can't multiply two numbers together like we would in every other VM. Is everyone aware of that? Who here knew that multiplication was disabled on Bitcoin for security reasons? Very few. Division, multiplication, left shift, right shift, even concatenating two variables together. All disabled. Why? Because Satoshi wasn't that good of a programmer and made some very bad mistakes early on. And rather than fixing those mistakes, we just disabled them. And they haven't been enabled ever since. And it's been nearly a decade since that happened. But with BitIDE, we can make a polyfill for multiplication. So here we have uint15 multiplication, and you can see how we do it. We first decompose a number into bits, right? So, are we a techie audience? Are we a techie audience? Okay, so let's say I don't have L shift and right shift, right? So I can't individually manipulate bits within some number, right? How do I check in an n-bit number if the most significant bit is a 1 or a 0? I check if it's greater than or equal to 2 to the n minus 1, right? And do we have greater than or equal to on Bitcoin? We do. We do, right? So what do? Well, over here we can see in our num to bits 15, well in this case we're checking, it's like the inverse, right? So we mark it as a 0 if it's less than 2 to the n minus 1, but you guys get the idea. We can decompose a number into bits, so like let's say I want to make a new script. And let's add a constant to the stack. I don't know, 1337. And then let's go ahead and decompose it into bits. So we can do op, num, 2 bits.
Can you zoom in?
Oh, sure.
Thank you for letting me know. Is this better? Is this what?
No.
This is better, yeah? Let me first, okay, so in BitIDE, when you want to run a script, you just click run script, right? And then we can see the compiled result in normal Bitcoin assembly over there. If I want to decompose this into bits, I can just do, since I've defined a custom opcode over here, all of these opcodes exist on Bitcoin, right? But op num to bits 31 does not. So what do? We write a polyfill, and then over here, when we want to go and execute it, we do op num to bits 15, 31, all the ones that we define in our operations or our opcodes folder. And we can see the result, right? So if I go over here, we can see that
This is 1337 decomposed into bits. Now, why do we want to decompose numbers into bits? Well, because multiplication of 2 n-bit numbers, right, is the same as saying we want to sum over all the bits and do a shift multiplier. Anyone familiar with shift multipliers? So if I want to shift an element up a certain number of bits, one way I can do it is by using L shift and right shift, but we don't have that. What's another way to do it? We can do it by multiplying a number by 2, but we don't have multiplication, but we do have addition. So we can do op-add or op-dupe to duplicate an item on the stack, and op-add to multiply by 2, right? So in this way we can implement a shift multiplier, so that if I have 2 numbers, like 1337 and 420, we can do,
it'll be faster. Op, mul, U15. Those are both U15s, yeah? We can do optimal U15 and see the result. Now let's check our work. So if we go 1337, there we go. If we go 1337 times 420, it is in fact the right result. And we can see the compiled Bitcoin script over here. So this is the script that you
get out. This is valid Bitcoin script that computes the product of those 2 numbers. Now with BitIDE, it also makes it really easy to test tap scripts. Because testing tap script normally involves setting up some library or something and then having to like manually set up all the various like PBSTs or the tap tree. It's a lot of code. It's like hundreds of lines. But with BitIDE, it's very simple. So over here we have a script that checks if some value that's provided by the witness hashes to this value over here, right? So over here we include an example witness, and after that the script gets chopped off, right? So because in Bitcoin, whenever we want to spend a UTXO, what we're doing is we're providing a witness and an existing script that checks to make sure that the witness is allowed to spend some transaction. So the classic example is, let's say I want to have a multi-sig, right? I can provide the signatures in the witness and have the code, which is fixed for the UTXO, check to make sure that those signatures are actually, part of the multi-sig, or correspond to public keys on the multi-sig. So if I go over to our tap script runner, and we head over here, and we go to our pre-image lock, we can compile the UTXO, fund via RPC, it's going to fund the new UTXO, and then, once it checks it, we can go over here. If we want to use like some kind of check sig or something, you can also, it also has a wallet manager for Bitcoin, Liquid, Dogecoin, etc. We can use our example witness and unlock our UTXO, head over to the block explorer that it's set up for us, and we can see that in fact, what is this transaction? Well, we push, we check, there it all is. So yeah, like that's, I guess, BitIDE in a nutshell. It's the first IDE for Bitcoin, and yeah, we built this because we were building so much stuff on Bitcoin, and it was really bad using everything else. So if you ever want to try, we have it for, again, both Bitcoin Liquid, which is like the blockstream like fork of Bitcoin, and Dogecoin. So we actually also just implemented op 16, or op-check groth 16, which is like a groth 16 verifier for Dogecoin. Soft forks are coming very soon to Dogecoin, like probably within the next few months. So hopefully that gets merged, but and that's also supported in BitIDE already. But yeah, let's head back to the PowerPoint. So yeah, like BitIDE is really cool. It's really easy to mint ordinals, like again, just a command away. And if you want to build on Bitcoin, we want to make it easier. Come talk to us. Like overall, QED isn't just committed to our own protocol. We want to make the Bitcoin ecosystem very big, because like the better Bitcoin does, the better all the layer 2s on Bitcoin do. But yeah, so we implemented, it's on GitHub if you want to check it out, a groth 16 verifier opcode for Dogecoin. Bitcoin Core probably not going to add a groth 16 verifier, which is like a zero knowledge proof verifier for like in an opcode very soon, but we actually fit the proof within all of the existing constraints on Dogecoin. So it fits within their like 4,000 weight limit, and it just requires literally adding one operation to the script eval, or the script evaluator, which we have implemented. But yeah, if you don't want to build, like, I guess, directly on Bitcoin, you can also build on L2O. So L2O is our consortium that implements standards for ordinals based, you can think of it as federated rollups, but other applications in general. Like you can build any zero knowledge application and then deploy an L2O ordinal, which will enforce that, you know, every time someone posts a proof for some L2 ID, that it has a valid state transition, it'll keep track of that for you, and also make sure that the zero knowledge proof is valid. So you don't have to, like, let's say I want to make a new application or a new standard on Bitcoin. I don't have to make a new indexer, right? I don't have to ask all the nodes to install my indexer. We have one Turing-complete indexer that doesn't require a gas token because groth 16 proofs are constant size, right? So no matter how long my computation is, the time it takes to verify the proof is exactly the same, right? Incredible. But yeah, so we want to bring internet scale and BTC native security to Bitcoin without increasing the block size, because we all know how that went years ago. And we don't have to increase the block size to get more computation out of Bitcoin now, because we have succinct zero knowledge proofs. But yeah, so I'll skip through this. We support lots of cool stuff. We have also native support for trustless support for like you know, BRC tokens, other ordinals, NFTs, and such. But yeah, the rough sort of like, I guess, way that it works. Why am I not doing this in full screen? I very much apologize. Yeah, so like essentially you first inscribe the verifier data for some zero knowledge circuit on Bitcoin, and you claim an L2O ID. And then after that, we have like a deposit tree that's maintained by the indexer. And that's okay, because in order to create a deposit event, you need to do an on-chain Bitcoin transaction. So it's like, it's expensive, so people can't DOS us like that, right? And then every time I like send off, let's say a state transition proof, or in the case of a layer 2, a block proof, the indexer verifies the proof, makes sure that they are adhering to our public input schema. So you can imagine inside the proof, you have to like output certain values. It's actually the public inputs, but it'll include your start and end state roots, right? So we make sure that on block 10, your start state root is the same as the end state root on block 9, right? So it doesn't just matter that we have a valid proof, we also have to make sure that all of the block proofs like sort of line up back to back, right? And then, yeah, so the indexer maintains a canonical state for the blockchain, and the only way to break it is to break Bitcoin's proof of work itself. So like, I guess the test for any so-called trustless solution is pretty simple. Like, the way that we guarantee Bitcoin security is by playing the Bitcoin blocks back from Genesis. And if you have a solution which is secured by only that alone, meaning that I can verify the current state of some layer 2 based solution just by playing the Bitcoin blocks back from Genesis, then that means that blockchain has what? Bitcoin security, right? If you can't determine the state of the chain only by playing the Bitcoin blocks back from Genesis, then that is not Bitcoin security, right? Because this is how Bitcoin security works. But yeah, if you want to just build applications on Bitcoin though, and you don't want to worry about making your own protocol, you just build it on QED. So we're horizontally scalable. Everything's proved end-to-end. We don't do like proof of stake, proof of work. Like as I mentioned, I used to have to run like POS nodes with billions of dollars staked into us, but like I saw that what ended up happening is the exchanges that like held the coins for the users started voting on behalf of the users with the users' funds. And then that just means that it becomes centralized in the hands of a few exchanges. Yeah, so like that doesn't really work. Yeah, proof of math is the only good proof. I mean, proof of work is great, but it's not very environmentally friendly. So we should just sort of, I think, coalesce around one proof of work chain like Bitcoin and kind of call it a day. We have proof of math now. But yeah, so like fast recursive zk-PARTH is super OP, and we take well advantage of it. So the way we do horizontal scalability, I'll sort of skip through this. I don't know how interested people will be. But yeah, so like when you prove in QED, it's quite interesting. You can prove all of your transactions locally. And then like, I'll skip through here. What we do is we both do proof aggregation and also state coalescence at the same time. So like everyone knows proof aggregation, that's like not a new thing, right? Like taking a bunch of proofs and making them into one. But we also process like the state from, or the corresponding state changes from each proof or each stage, as well as doing the recursive verification, which means that at the end of this proof aggregation process, we also have a state delta proof. So we've also just created a block proof. So yeah, like users prove their transactions, and then once they're done proving their transactions, we can see over here that we are able to, in parallel, generate that and recursive block proof. And specifically, like, yeah, it takes other chains a lot longer. Like, yeah, it's like a joke. Like we verified these numbers on AWS. QED is very fast. In general, like our block times are O of log base 4 of n, where n is the number of users that are transacting in a block, which means that like having 1 million users versus 2 million users only makes our block time twice as long. Or I'm sorry, log n times as long, right? Not twice as long, that would be bad. But it only makes yeah, it's very fast. Sorry, not much sleep from all the events, but you guys can see like, yeah, for P though, because O of log base 4 of n is great, but if like the constant is very large, then it still sucks, right? You could still have day-long blocks, right? But on QED, in each of these proofs, we're recursively verifying 4 child proofs, as well as processing those state changes. And to do that 4-to-1 recursion, it takes like 500 milliseconds. So yeah, like this means that we can process millions of user operations per second. Yeah, we've tested these things on AWS, and I just want to end it off by saying like, why should we care about scaling Bitcoin security, right? Like, why does it matter? Like, do people really use these like blockchains that have super high TPS? And the answer is no. Right? Because like no one has ever built something that's truly decentralized or that has the same security that we want with blockchain, but is also able to scale. It's always been a trade-off. It doesn't have to be anymore, and this is kind of a point of reckoning for blockchain, since blockchain hasn't impacted most people, and like impact is basically usefulness times the number of people that you impact. And we want to build a provably fair internet for all, not just existing crypto users. And yeah, like you can build things on QED that just weren't possible on other blockchains. So like you want to build a really high performance order book DEX, you can do it on QED. Ultimately, like scale is not just a narrative, it's our responsibility because of the amount of capital that humanity has dedicated to blockchain. Like think about how much money has been blown on blockchain thus far. It's an enormous amount, and like most people haven't gotten much out of it. So like it's our job to get blockchain in people's hands and make sure that we have a positive rather than a negative impact. Yeah, that's it for today. If you want to work at QED, we're working on really cool stuff. Send an email to jobs@QEDprotocol.com. We're hiring like as many people as we can. Take care.